Okay, one of the things you learned yesterday was how to do 5 choose 3 like this. 5 choose 3. There's a button on your calculator called NCR, and NCR is under math and then probability. Would you please type in 5C3? What did you get? 10? All right. What does it mean again? It means if I have 5 things, these little star thingies are all slightly different, of course. If I wanted to choose sets of 3 of them, the thing is saying there would be 10 different sets of 3 that you could pick from that. All right, and again, this is the formula for it, but I am not expecting you to memorize that. I'm expecting you to know how to put it in the calculator. Well, where did that come up? It comes up in this formula. I'm going to pause for a second while I get the formula up. This is officially the binomial theorem. And the beginning of it isn't too painful to read. It's if you have a plus b to the power of n. What is that little Greek letter right here? What's that thing called? Sigma. Okay, that's sigma notation. And it's saying we're going to go from 0. A lot of times we start with 1, but here we start with 0 to n, which is what? Well, it's the same n that's over here. So it's whatever power you're putting it to. And this will generate all the terms. If you want to follow this through and figure out, okay, it's got a little thing in front of each term. Remember, it's the like 3 choose 2 thing. That'll be your biggest number. Let's say it's 3 choose 0, and it starts with 3 choose 0, and then it's 3 choose 1, etc., etc., etc. And then this is saying your 2 things right here, A and B, are put to those respective powers. I think it's so much easier to actually do this than to try to understand it. All right, so I'd like you to look on this page. Do you see how it says 2x plus y to the 5th there? And it's asking you to do the expansion and just do this part. I actually want you to do not the whole expansion, but would you just do the first 2 terms of the expansion of this? Hint, you start with 5 choose 0. And then do you remember that the 2x's are going to be starting with a big power and then going down? 2x to the 4th, 2x to the 3rd, etc. And then do you remember how the y's are going to start with a 0 power? Y to the 0, y to the 1. That's what this fancy formula here is telling you. But again, you don't have to regurgitate that formula. We're giving a formula sheet. And you don't even have to know how to use that formula if you can do this by just seeing the patterns. There's the first parts. This is not the whole thing, but I did do the whole first term for you. Would you please figure out what the whole second and the whole third term are? I'll pause for a second while you figure that out. And actually do multiply it all out. Like that 2 to the 4th, that's a 16. And there's a parenthesis here. Something choose something. Okay, I'm going to pause for a second while you work out the next couple terms. Okay, by now, if you understand this, you know this is a 5 choose 1 and a 5 choose 2. And then I got to put in my remaining, my y's were going y0, y1, here's y to the 2nd. And then I will simplify these a bit. 5 choose 1, I can do that one in my head. If I have 5 marbles and I choose them one at a time, how many ways I can do that? 5. And then the 2x to the 4th, the 2 to the 4th is a 16. Some people are going to not see where that came from. That was 2 to the 4th. Then it's x to the 4th, and then it's y. Now the 16 and the 5 can go together. 50, is that 80, I hope? 80x to the 4th y. Raise your hand if you got the same thing I got there. All right, good. Any questions about term 2? And then the last term. 5 choose 2, I don't know that one off the top of my head. Did we do that one? Is that 10? Okay, so then if this is 10, and then this 2 to the 3rd, 2 to the 3rd is 8, x to the 3rd, y squared. That would be 80, x to the 3rd, 2y squared. That'd be your third term. And now, if you look back at the question they originally asked, do you see it says the term containing x to the third? Well, that's this one right here. You'd have to write out that as your answer. Does that make sense? All right, let's do one more expansion like this. 5x minus 2y to the 17th, and I just want the the 18th term. So in other words, don't start at the beginning. I want the last term. I'm going to pause for a second while you figure out the last term of this binomial expansion. If you really want to, you could start at the beginning like you were before and try to catch the pattern and then go to the end. I'm actually going to start with the first term just to get that pattern down. This is 17, choose 0. Instead, I can just think it through, and it'd be 17, choose 1, and the next one at the end, it must be 17, choose 17. Remember how I said there would be 18 terms? This would be the 18th term, the last one. Okay? And then, how about the other ones? Well, the 5x would be to the biggest power at the beginning, 17. And then it would go down, 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 down. And then, do you get how this would just be 5x to the 0? Which really doesn't do anything. There's none of the x stuff in that last term. What is in that term is the other one. Because the other one, the negative 2y to the 0, and then it goes up, 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 then this is going to have a, if I could fit it right there, it would have a negative 2y to the 17th. Now, 17 choose 17, thankfully, that's really easy. I have 17 reindeer to choose from, and I have to pick 17 of them. There's only one way to do that, so it's 1. That's 1. And then this one's 1. So it's really just this, negative 2y to the 17th. And I totally understand if you left it that way, because I don't think many of you know what 2 to the 17th is off the top of your head. How about this? Is the answer positive or negative? It's negative, because that's an odd number. It's going to be multiplied by itself an odd number of times. There'll be a leftover negative after a bunch of them cancel. All right. Here's another question along the same lines with this same problem. Would you tell me the term that has y to the 16th in it? Tell me the term that has y to the 16th in it. There is a fancy way you can do this with the formula and setting things like, okay, so that old formula had the J and the N and all that stuff, and you could do it with the formula, but the easiest way is to just think about it, write out a few terms, figure out which one would probably have y to the 16th in it, and do that term. It's near the end, hint, hint. The very last one would have negative 2y to the 17th. Therefore, it was this one that had negative 2y to the 16th in it. And so this one was 17 choose 17, so this one would be 17 choose 16. And then it would have some x's in it too. These x's that at the very beginning would start with 5x to the 0, but then go up from there. No, 17, sorry. 5x to the 17, but then go down from there. Those 5x's, by the time you're near the end there, they're almost out, but you'd still have a 5x to the 1 left. This very last one would be 5x to the 0, but this one would have a 5x to the 1, and since it's to the 1, I can just leave it as a 5x. There's your answer, but not simplified. Your final answer, that's 17. negative 2 to the 16th, I have no clue what that is, but I can tell you it's even. And then y to the 16, and then a 5, which I can put up here, and then an x. You'd have a calculator on the test. So you'd be able to figure out exactly what all this multiplies to. But I can tell you it'd be some number, and it's positive, and it's big. And then it has a y to the 16th and an x. Yes? Where to get the 17? That was 17 choose 16. Is that correct? I think 17 choose 16 is 17. Okay. Where do I plug it in? It's a constant. It's in front. So when you use the calculator and figure out what 17 choose 16 is, it'll be 17. So it's a constant. It's the number in front of the term. But I also had a 5 from back here, and I moved that 5 up to the front to multiply by the 17. And this negative 2 to the 16th is also buried in there. Makes it a very, very big number. Okay, and one last one from beginning to end. This is our last practice on binomial expansion. If I say 2x minus y to the third, it may seem simple now because we've been using these ridiculously big powers like 17. Just write out the whole thing. All how many terms? All 4 terms of it. I'll pause for a second while you give that a try. Okay, first 4 terms of this is, first up, 3 choose 0, and then 2x to the third, and then negative y to the 0. Simplify that down. That's just a 1. There's only one way to choose 0 of something. And then 2 to the third is 8. X to the third. That just becomes a 1 right there. So there's your first term. Raise your hand if you had that one right. Awesome. Now, save me some time to do the next 3 terms. I'm going to call on different people. First of all, it is row 2, person 2. That's you. Tell me the next term.
12x squared times negative y.
Can anybody verify 12? I'm going to say negative 12x squared and then a y. Raise your hand if you had that same as him. All right, good. Then next. Hello? Is row 4, person 4. Right there, you in the red shirt. Don't like to say names in the video. 6xy squared. Can anybody verify that one? A lot of people. Good. And that's positive. And it does seem like logical. It'll go back and forth between positive and negative, right? Okay. And now, the last one probably is negative then, because your y, your negative y, is being put to the third power, and that'll be negative, right? Okay. And the very last term, row 5, person 5. Last person in the row. What'd you get? Just negative y to the third. Okay, cool. So that's it right there. I can take the parentheses off even. Okay. How many of you got this all right? Good. Then binomial expansion should be the easy part. Okay. To finish this one up, just a one blast from the past. Can you tell if this is adding something each time or if it's multiplying by something each time? Well, if you make the first few terms, you probably start getting the idea. So if I put a 1 in, n equals 1, I would get 8. If I put in a 2, I would get 16. Now that looks like it might be timesing by 2. But if I put in n equals 3, it's 24. And then you notice, oh, it's just adding 8 each time. So if this is an arithmetic sequence and I want to add up the first 8 terms of it, I could either write out all 8 of them, or I could use one of those formulas for the arithmetic. A sub n, the sum formula, to sum up those first n terms, in this case 8 terms. and it goes like this. A, actually we put n over 2 here. That's how many terms we have divided by 2. And in this case, we have 8 terms that we're adding up, so we're going to 8 divided by 2. Then, inside here, we take the first one plus the last one, which is a plus d times n minus 1. And then I'm going to stick in the numbers that I know. 8 is the first number. All right, so you stick in 8 for the a, and then the d here is we're adding 8 each time, so that's why that's an 8. And then the n minus 1. Okay, so now we're going to put in the n, which is 8, and so that's 8 minus 1. So now we have 7 times 8 is 56 for this part, and 8 plus 8 is 16. So we have 8 divided by 2 is 4, and then 16 plus 7 times 8 is 56. 4 times 72, and there's our final answer for this series, which was given to us in this format. 288 is the sum of this series with this sigma notation. Okay, that's the last example problem I have for now, and you don't have any homework assigned in honors pre-calc over the break. We will be reviewing for and then taking the test on the Friday when you return. And that's all I have for you for today.